Example 3. In this example, all we have to do is to decide whether a series is convergent or divergent. Okay? Is the series. The series is defined using sigma notation. So we're going to say that we have S sub n is the sigma, n goes from 1 to infinity, of course, it's infinite series, 2 to the power of 2n times 3 to the power of 1 minus n. And is the series, this series is divergent, convergent, or divergent. All right, look at it and tell me what's your gut feeling about that, just by looking at it. Is it something that will end up converging, or it's something that will blow up? Divergent? Divergent? Can you tell me, let's see, who? Go ahead, Greg. You said divergent. Tell me why. And Josh, you said no actually, so I'll get back to you in a second. The two numbers, the two factors, 2 to the 2n and 3 to the 1 minus n, will go to infinity. But to contradict you, one will go to negative infinity, the other will go to positive infinity. So that was your answer, and it seems that other people agree. And Josh, you said convergent, right? Did you say? I thought I said. No, you are neutral in this manner. You are not, because 1 minus. And this is a good thinking. So let me repeat what Josh said. It's actually, I alluded to that. He said because we have 3 to the 1 minus negative n, or 3 to the negative infinity will go to 0. So that implies, right? That this thing will converge. The answer is it's a divergent series, and let me show you why. Okay, the first thing, well, we need to assume something. We're not going to assume actually, but let's play what if. What if this is a geometric series? Nobody says that this is a geometric series, but maybe it smells like a geometric series. It cannot be arithmetic. It's not anything else. So maybe it is a geometric series. If it's a geometric series, then we have a clear test. If R, the ratio, is greater than 1, the absolute value of R greater than 1, then it's divergent. If it's less than 1, then it's convergent. So what we want to do, we want to see if you can identify A and R, the two parameters that indicate a geometric series, and then if R, the absolute value of R is less than 1, then we know. Okay? So the first task is to try to make a geometric series out of this. So first, try to write the series as a geometric series. Okay. Now, so let's work with what we have. So it's the sigma, n goes from 1 to infinity, 2 to the power of 2n times 3 to the power of 1 minus n. So far I didn't do anything, I just rewrote it. Now I'm going to start breaking down. Okay, I see 2 to the power of 2n. Well, this can be written as 2 to the 2 squared raised to the power of n. Agree? Just using property of exponent. Now, for geometric series, I'd love to have and to the negative 1. Remember that we go back to the structure where we have r raised to the power of n minus 1. I don't have n minus 1, I have 1 minus n. But if I write it as 3 times negative, I'll factor the negative sign, then I have n minus 1. Furthermore, this will give me a denominator raised to the power of n minus 1, which is really good. Alright, so next step, write it as sigma, again, n runs from 1 to infinity, 4 to the power of n, right? Now, this will be dropped to the denominator. I can write it as 1 over 3 to the n minus 1. Then last step, or next to last, I want to come up with a fraction or a ratio that goes to the power of n minus 1. Well, I have a numerator that goes to the n. So what I'll do, I'll factor out the 4, and now I have 4 raised to the power of n minus 1 divided by 3 to the power of n minus 1. And I'm almost home, because now I can write it as sigma from 1 to infinity of 4, and then we have a common power, so it will be 4 over 3 n to the negative 1. Now tell me, is this a geometric series? And if it is it the convergent or divergent? It is a geometric series because what I've come to is to sigma n goes from 1 to infinity of a times r to the power of n minus 1. And now a is 4 and r is 4 over 3. And because r is greater than 1, the series is divergent. And let's write the conclusion of this exercise on the next page. So a equals 4 and r equals 4 over 3. Okay? And 4 over 3 is greater than 1, therefore it's divergent. And that will be the answer. Be nice if I was able to squeeze it at the bottom of the previous page, because I want to keep usually an example in one place, but it is what it is. All right, so I'll go and move on to the next example.